I mentioned I'm director of this research center. The adaptation refers to adaptation to climate change. So it's a climate change research center. And it was actually, the idea came out of Ottawa in the 1990s. Natural Resources Canada wanted to put a climate adaptation research center somewhere in Canada, and they chose Regina. The reason they chose Regina was because PFRA was there. You may remember PFRA, the Prairie Farm Rehabilitation Administration, a federal crown corporation with headquarters in Regina. And that's the reason they gave. The fact that the Minister of Natural Resources was my local MP was probably a factor, but they didn't make that public. Ralph Goodale. So we worked closely with PFRA until the Harper government got rid of it. And we've always worked closely with the ag sector, although we also work with oil and gas and municipalities, Calgary, Edmonton, and so on. And I want to thank, so we're always linking climate adaptation to what's going on in agriculture. And in recent years, linking climate change to regenerative agriculture. And I want to thank Mike for inviting me to come out here. I was looking forward to the drive. I figured it's a chance to take a bunch of pictures to illustrate my talks, but it was foggy and raining the whole way. But I had to stop, so I eventually stopped at Grand Valley, just right over here, and took a picture. Because I want to talk about this weather. I always begin a speech about climate change with the weather, because we're all comfortable talking about the weather. We're not comfortable talking about climate change. And I appreciate, sorry, I missed your name already. What was your name again? Roger. I really appreciate the fact that you said, if the climate is changing. I like that attitude. Even though I know the climate is changing, I've been studying climate change for almost 40 years. I know it's changing, but I don't know how other people know it's changing. I mean, I have access to huge global databases of temperature and so on, and I have access to computer models and so on. But how does the public know the climate is changing? And I speak to some audiences in the city where they're all really concerned about climate change. And I say, well, how do you know the climate is changing? Well, in the paper, it's in the paper. Okay. The fact is, climate and climate change is a very abstract idea. If you want to read a good book by Mike Hume, it's called Weathering, the Culture of Climate Change. And he says that climate is actually made up. The whole idea of climate is made up because it's the average, and the average doesn't exist, right? But he's a famous climate scientist, and he was saying that different cultures have different definitions of climate and climate change. So let's start with weather. This weather, which is somewhat strange. In fact, I downloaded the weather data for Brandon for the last 2 months. So we're 2 months and a week into winter. We're almost done with winter because technically winter is December, January, February. So in 3 weeks, we'll be done with winter. So here's the first two-thirds of winter at Brandon. And this is the daily maximum in blue and the daily minimum in brown. And these temperatures actually exist because it's when the thermometer bottoms out and when the thermometer peaks. The average doesn't really exist. And you can see it's crazy. I mean, especially December. Very few days when the maximum temperature was, well, it was pretty much in the range of 0 to -5 throughout December. Well, you were there, you remember, right? And then we had 2 weeks of winter. That little blast of cold air a few weeks ago lasted about 10 days. That was basically our winter, because I can add another week. We've had another week of warm weather. And if you look at the long-range forecast, most of the rest of February is going to be above average. I've seen temperatures of minus 18 in the forecast. That's still above average. So this is the weather we got, but this was the weather we expected to get. This is the what we call the climate normal. This is the average maximum minimum temperature for the period 1991 to 2000 for December and January. And you can see that throughout the entire month of December, both the maximum and the minimum was completely above average. Some of both in January. So the solid line is the weather, the dashed line is the climate. Because the climate is what you expect. The weather is what you actually got. And add something else. So this is the most recent climate normal. And we use 30 years because in the 1930s, a whole bunch of climatologists got together in Poland and defined climate as 30 years of weather. They had to choose a number, they chose 30 years. So unless you have at least 30 years, you can't even describe the climate. Anything less than 30 years is not climate. So that's the most recent climate normal. Here is the normal climate from 1941 to 1970. So some of you may have been around in the 1960s and 70s. So this is the climate you remember. The thing to note is the climate normal has gone up. That is climate change. Right there, climate change does exist. If you define climate as 30 years of data, then there's no denying that the climate has changed. I'm not saying how it changed and why it changed and what was the cause, just we're looking at climate change. And you can see that the increase is larger for the minimum temperature than the maximum temperature. So our low temperatures are increasing faster than our high temperatures. It's really important that we recognize the difference between weather and climate, because a lot of the confusion and a lot of the disagreement is because somebody's talking about weather and somebody else is talking about climate and they don't realize it. For example, you hear people say, wow, this is climate change. No, it's not. It's the weather. Now, if it stayed like this for 30 years, yes, that's climate change. Or you hear people say, we have a dry summer, that is climate change. Or we have a dry decade, that's climate change. No, it's not. A dry day is the weather. A dry decade is climate variability. It's not climate change. So the difference is, this is all temperature, rain, snow, wind. It's all the same variables, but weather is hour by hour and day by day at a single location. When you look up the weather, you don't look up the weather for the world. You don't look up the weather for Canada. You look up the weather for a single location. Okay, so it's scale. At the other end, climate change is global, and it's on the scale of decades, at least 3 of them, and centuries to millennia. And then in between is this really important middle ground that we call climate variability, from month to month to decade to decade. So we have seasonal climate variability, and we have year to year and decade to decade climate variability. The thing is, those are cycles. They cycle back. You can have a warm decade, or let's say a wet decade, and then it cycles back to a dry decade. And that's where you have to be careful where people conclude that because we've had 10 years of wet weather, that's not climate change. It's bound to cycle back. It's reversible, whereas climate change is irreversible. It might be reversible at the scale of ice ages, but over centuries and millennia, climate change doesn't turn around. Okay, so, and I've also indicated some of the indicators of weather, rain, storms, heat waves. Indicators of climate change is like rising sea level. It's a change in the frequency of extreme events. It's the wastage of ice sheets. So it's very different than weather, right? And in between, well, what drives year to year and decade to decade variability? It's pretty much the oceans. 3/4 of the Earth is oceans. The oceans store a huge amount of heat and water. And so when we get wet years and dry years and wet decades and dry decades, it's being driven by El Nino, La Nina, and a similar but decadal oscillation. So El Nino, La Nina is like year to year. The PDO is decade to decade. So that's my course in climate science. I teach a 1 semester. Right now I'm teaching a 1 semester course using my phone. So I can be here and be teaching during the coffee break. And I just reduced that 1 semester course to pretty much this slide. Because I think this is the key information, is understanding the terminology so we're all speaking the same language. Climate change is a global phenomenon, so it's most obvious at a global scale. So here's the temperature of the whole world every month back to January 1880 and up to the end of last year. And if it was a warm month, it's red, and if it was a cool month, it's blue. And you can see that ever since the mid-1970s, every single month has been warmer than average, except for one. I think December 84 or 85 was a cool month, but that's a single month. And so this is pretty conclusive. Something is going on. The world's getting warmer. Now, the warming isn't constant. There are some years in which there's much more warming than others. And other years, like you can see, there's a few dips. There's a few white dips where it was warmer than average, but not much. There's a lot of natural variability embedded in there, and that's from El Nino, La Nina, the circulation of the oceans, and so on. If the natural factors are in sync with the human factors, then they amplify each other and you get a super warm year. Other years, the natural factors are causing cooling and the human factors are causing warming, and the net result is a year that's not much warmer than average. So it's important that you recognize there's some natural variability there. And so this is a very powerful graphic, but there's some problems with it. The temperature of the whole world doesn't exist. You can't find it on your phone. It's just a statistical concept, right? But also, it kind of gives people the impression that the world is sort of heating up and drying out and blowing away. Because if you Google global warming and choose images, this is the most common image you see. So this is the kind of image that's used to fear factor, right? Now, is this likely to occur? Maybe there's a few places on Earth that could get this dry, but this could only happen if we had extremely high temperatures and virtually no precipitation. So let's look at the likelihood that this could occur here. Let's look at the historical record at Brandon of high temperatures. It's hardly going up at all. And Brandon has a fantastic weather record. I think it's because of the Ag Research Station. But there aren't too many places on the prairies where the weather records go back to 1890, and there's no missing data. And you can see, if you read the vertical scale, the average maximum summer temperature, so that's the highest temperature every day averaged for the whole summer, has gone from like 24.5 to just about 25. Not even half a degree of warming over 130 years. It's not getting hotter in summer, despite what people think. So many people tell me it's getting so much hotter. Okay, well, that's our perception of it, right? But the data says it's not getting hotter in summer. Now, there's a huge amount of variability. The hottest summers have been the driest ones. 1961, 1988, in particular, those two peaks. And look at this. The coolest summer was recently. So if you look at summer weather at Brandon or anywhere on the prairies, it's hard to see climate change. You can't conclude that the climate is changing. What you see is a whole lot of variability from year to year. Now, when I use this, people think, oh, you don't believe in climate change. Well, obviously it's not true, but people have been trying to explain, at least scientists are trying to explain why it's not getting hotter here in summer. And there was an interesting piece of research done by some Ag Canada scientists who said it could be because we've taken the native ecosystem, the prairie grassland and the parkland, and we've taken it and converted it to agriculture. So we've probably had a profound effect on the climate of this part of the world because we've taken perennial vegetation and converted it to pretty much annual vegetation. So they're talking about a reduction in maximum temperature. These findings are in opposition to the trends you would expect from climate change. And that it has something to do with, first of all, we practiced summer fallow, which would heat up the air. And then we got rid of summer fallow, which would then cool the air. But it probably also has something to do with the fact that in the perennial native vegetation, as soon as the snow melts, this vegetation is photosynthesizing. Whereas in the cropland, of course, there's a period in the spring before the plants emerge when the plants are not participating in the hydrological cycle. So this is really interesting piece of work suggesting that we've changed the climate of the whole world by burning fossil fuels. We also may have changed the climate of the prairies by practicing agriculture, but in the other direction. So yeah, we can't see climate change in the maximum temperatures, but the fact is that summer's getting longer. That's the key. Summer's not getting hotter, it's getting longer. Let's look at September temperatures. And I have producers tell me that when they're harvesting, they've noticed that it's just warmer at harvest time. Not every year, but often. And in fact, here's the minimum daily temperature at Brandon, again back to 1890, in September, and it's gone up quite a bit. I mean, there's been a couple cool Septembers, but other than these two cool Septembers, the September minimum temperature has been pretty much above 4 degrees, which means there's probably less frost in September than it used to be. In fact, a lot of locations this past September had no frost in September. The first frost was in October. I can remember we would get frost in August. We get frost in late August, and certainly we get frost in September. Now it looks like we're not getting frost until October. That's probably climate change. And if summer is getting longer, there's just more days of evaporation. So if summer dries out, it's not because of super high temperatures, it's because you're getting evaporation in September, May, even April. whereas in the past, you didn't get much. That's the way I see it, because Canada is warming up. Here's a map of Canada from Environment and Climate Change Canada. This is the weather station data back to 1948. And the darker the tone, the more the warming. Poor Newfoundland is not warming up at all, and Labrador. Most of the warming is in the west. Okay, so Western Canada, especially northwestern Canada, is warming 4 times faster than the rest of the world. And most of Western Canada is warming twice as fast as the rest of the world. But you can see, here's that little hole again. Here's this little global warming hole that I just talked about, but it's still warming. I mean, it's warming as fast as Ontario and Quebec. So most of the warming is in the west. I want you to compare that to this map. This is a map of whether people think it's warming. So these researchers from Montreal talked to thousands of Canadians and said, do you think it's getting warmer? And that dark green is 90%, 95% of people think it's getting warmer. The least acceptance of climate change, surprise, surprise, is on the prairies. I think we know that. We're about half the people surveyed in Alberta, southern Saskatchewan, parts of Manitoba, about half the people think it's getting warmer. It's kind of ironic that the highest rates of warming are in the west, and the least perception of warming is in the west. This, we call it cognitive dissonance. So this research was done in Montreal, and it's a head scratcher. They can't figure out what's wrong with us people out there. And I have colleagues in like Vancouver and out in Ontario that say, what's wrong with you people? And I say, there's really nothing wrong with this. You don't know much about our part of the world. And I've had the good fortune, like I said, of hanging out with producers a lot, and I have family who farm, but also we do research on it. Amber Fletcher, who grew up on a farm in northeastern Saskatchewan, is a professor of sociology now, worked with Amber Fletcher, and she talks to a lot of producers. I have a research assistant, Sheena Stewart. I encouraged her to do a master's thesis in psychology, and it was funded by the Saskatchewan Watershed Association. Water Security Agency. And she also talked to a lot of producers. And sure, there are psychological arguments where people don't only trust the opinion of somebody they know. We all do that. It's not just producers, right? So you tend to think like other producers. And people in the city tend to think like other people in their neighborhood. So there are some psychological characteristics, but Amber has discovered it has a lot to do with our personal experience with the weather and the climate. And if there is uncertainty, if the climate is not certain, then people resort to their own experience. It's just human nature, right? If the experts can't give you an answer, then you think, well, what has been my experience? And for most producers, they experience natural cycles. And I already showed you in those graphs, the amount of change is tiny compared to the year-to-year variability. So unless you're super old and you remember the climate of the 1940s, sorry, I'm not young either. I can remember the winter of 1969. Which was cold. This isn't cold. Yeah. So people who've experienced the weather for 60, 80 years have a database, have a basis for observing climate change. Most people just haven't lived long enough to experience climate change. And so what do they see? They say year to year and decade to decade variability. natural cycles. Or, I like to quote producers rather than believe a scientist. I gave a talk in Tabor, Alberta, to a group of producers, and afterwards, a manager of an irrigation district said to me, "Dave, nice talk, but I'll believe in climate change when we get unexpected weather." I said, "Wow, can I quote you?" And I use this all the time because this is the definition of climate change. If the weather has changed, if it's because I already said climate is the weather you expect. If you get unexpected weather, it means it's climate change. But that unexpected weather has to occur again and again and again for at least 30 years. So 1 year of unexpected weather is just weather. 30 years of unexpected weather is climate change. And how do you know if it's unexpected? We have the most variable climate on Earth, except for Kazakhstan. I like to go to Kazakhstan. I heard it looks like this, because Kazakhstan and southern Manitoba and southeastern Saskatchewan is as far as you can possibly get from an ocean in the entire world. The two places on Earth that are furthest, the center of North America, Rugby, North Dakota. According to Rugby, it's just over here, right? So the further you get from the ocean, the more variable is your climate, because water stores heat. So it prevents, the heat gets transferred to the ocean on hot days and it gets released on cold days. That's why people congregate in Victoria when they retire, right? And so we have the most variable climate. So here's 2 days in April, a day apart, but 8 years apart. I gave a talk in Swift Current. Coming back from Swift Current, I noticed smoke. I pulled off the highway near Moose Jaw, and there was a prairie fire because it was a really hot, dry April. Here's April last year. It's like the dead of winter. That's our front yard. This is my wife's regenerative urban permaculture. A few years ago, my wife, who's a retired plant ecologist, said, "Dave, get rid of the lawn." Okay. So I grabbed the shovel and I started turning over the lawn. I got halfway through and said, I should have rented a bobcat. But I was halfway through, so I got rid of the lawn. And she has planted 54 perennial plants in the yard. We haven't been to the grocery store in 3 years, except to buy dairy products. We produce enough food for ourselves and our children and their spouses in our urban lot. Now, we have a big lot, but even so. And on the left, I built some trellises. Those are grapes with the most fantastic grape juice throughout the winter. Anyway, it's possible in the city to produce enough food for yourself and your family, even though the neighbors complain. And if they complain to the city can make you
the grass back in.
Yeah.
And that goes back to the whole.
Isn't that crazy? Yeah, so the point of this slide was just that we have so much variability from year to year. It's hard to see if the climate is changing. But if you want to see the strongest indication of climate change in our part of the world, it's winter. Our winters are getting much less cold. So this is the minimum daily temperature, usually just before sunrise. At Brandon, back to 1890, if you look at the scale, it's gone from -22 to -19, a 3-degree change, which doesn't sound like much, but that's a lot. You know, about 60,000 years ago, North America cooled by 4 degrees. It took thousands of years. And what happened? A glacier formed and covered all of Canada. So a change of 4 degrees over thousands of years was enough to cause a glacier, the biggest glacier that's ever existed, to cover Canada east of the Rocky Mountains. Here's a 3-degree change in 130 years. And Brandon's not the best example. If you go north of here, there are some places that have had a 5 to 6 degree increase in winter temperature. And the best way to show this is, and it's funny because we whine and complain about winter, but it's much less cold than it used to be. So let's say that, let's just choose minus 16. So minus 16 and above, let's call it a warm winter. Look at all these warm winters. Before that, there were a few. And this is the warmest, just about the warmest winter we've had. 1931, a really strong El Nino. All these warm winters are El Ninos. But it's a combination of El Nino and global warming that's causing our winters to be so much warmer. Yep.
1931. The dust blowing in the black soil.
Could have been, I'm not sure. Yeah, it's possible. Yeah. Okay, so this is the weather station data. This is obviously from a climate model because this is the prairies, and it's the increase in winter minimum temperature when the whole Earth has reached 2 degrees of warming, which hasn't happened yet, but it will. Probably, we used to think 2050s, now we're thinking the 2040s. The whole Earth will have warmed by 2 degrees compared to pre-industrial levels. We're approaching 1.5 degrees. Almost 7 degrees of warming up in northern Manitoba. And down here, 3-4 degrees of warming. Now, this is from a model, but we don't have weather data for the future. So when people ask us, where is the climate heading? What's the climate going to be 20, 30, 50 years from now? We have no other option but to use the climate model. This is, and this is a lot of the work that the scientists who work for me, this is a lot of the work they do. I get outside and they sit behind fast computers and run these models. In this case, well, the technical details aren't important. They're boring. I find them boring, but this is the kind of stuff they're able to produce. So this is temperature. And then in terms of, and we've only talked temperature so far, what about precipitation? Well, here's the precipitation record of Brandon back to 1890, and it's been going up a little bit, not much. And you know, you might expect this because as the world warms, water's getting warmer. When water gets warm, it vaporizes. So actually there's more humidity in the air in a warmer climate, and it has to precipitate at some point. But that's a pretty slight increase of what, 10 or, well, maybe 30 millimeters. Compare that to the range. You know, some summers Brandon has had less than 100 millimeters. And look at this year, an incredibly wet year, but other years 350. So just the variability in the range swamps or obscures any kind of change. And this is why people have difficulty seeing climate change, because it's buried. It's buried in all that variability. You either have to be a scientist and do this kind of thing, or be very, very old before you can detect any change, right? So this is the historical record. This is the model. This is from the model. So this is summer precipitation when the whole world is warmed by 2 degrees. Southern part of the prairies, less precipitation. Up in these green areas, more precipitation, and the rest of the prairies somewhere in between. So for most prairie people, there won't be much change in summer precipitation, but there'll be a lot more evaporation. So we're going to lose a lot of water and gain hardly any. Yep.
So one common perception is that, of course, the 100 million barrels of oil equivalent that we burn every day has some impact on this. So in your models, you also got Earth's oscillations and various things that happen naturally. How do you account for the man-made things in your model, or use those to kind of prove that the temperature curves go down? Is that fair?
Yeah, that's a good question. And because we know that human activities are modifying the climate, we have to include that in the model. And all the modelers in the world got together a few decades ago and agreed on what are called greenhouse gas emission scenarios. And so there's a set of emission scenarios where one extreme, we do nothing about climate change. And this will be the future concentration of greenhouse gases. The other extreme, everybody bumps their head and we all become green and the world stops using fossil fuels. Both of those are unrealistic. It's somewhere in between, but there's a whole set of scenarios. And we have to choose one of these when we run the model. Okay, so we have these climate model projections. We don't say predictions because we're not sure. We have these projections of the future climate. We feed these projections into a crop model. Crop model is called DSAT, if you know anything about crop modeling. And so there's a scientist working for me, Dr. Mohammed Zare, and he's been running a crop model, starting with Saskatchewan, but we intend to do Manitoba and Alberta. This is spring wheat yield in 30-year periods, the recent past. And so here's the legend. Here's wheat yield in kilograms per hectare, poor yields, good yields, and of course, we all know that the semi-arid southwestern Saskatchewan has lower yields. And as you go north and east, there's higher yields. So we're going to go to the near future, which is now, until 2040, the middle of this century, and the last 30 years. And as you go forward, there's less and less red and more green. In other words, climate change is good for wheat production in Saskatchewan until you get later in the century. So some warming is good, too much warming is bad. So in the next few decades, with a longer growing season, more heat units, and enough precipitation, you should see higher yields. But eventually, as it warms, the evaporation overtakes the precipitation, and warming is bad news. And that's the bottom line from Mohammed's work, being funded by Southwest Terminal, which is ironic because Southwest Terminal is southwestern Saskatchewan, and this is the worst. The worst news is for their area. It's also being funded by the Canola Council and FCC, and there's a lot of interest in our ability to forecast crop yields, but we have to be pretty careful because, people own this land, and we're saying at some point it should come out of production. So we have to emphasize there's a lot of uncertainty, but this is the best information we have. And this, Mohammed doesn't run this once. He runs the model a whole bunch of times with different scenarios and different models. And so I'll just glance over this, but this is for each one of these is a different experiment. Using models from Canada, the US, the UK, the Hadley models from the UK. This is the Max Planck Institute, German model. So these are different experiments, and they pretty much all show that as you go from the past into the future, yields get better and then they drop off. But I want to show this because the whisker here is the range. And as you go into the future, the difference between a crop failure and a bumper crop gets larger and larger. So yeah, we're saying that there's an opportunity for higher yields, but be prepared for these crazy, we call it whiplash, from crop failure one year to a bumper crop the next. And how do you deal with that kind of volatility? What kind of insurance scheme do you have to get a crop off in a dry year when the previous year there was a ton of moisture? Will you hold that moisture somehow? Can you think about a way of retaining the moisture in a good year so it's available in a bad year? I'll make this point again. This is a better way of making it. This is from a climate model. This is spring precipitation at Brandon, according to this climate model. And look it says you're going to go from 100 millimeters in spring to 138. You're going to have 38 more millimeters of precipitation if you're still farming at the end of the century. And that's because, like I said, the water is heating up and is producing more water vapor. But how do you get from here to here? Well, the model says this is the path. Whiplash. Sure, there's a potential for higher yields, but you're going to have to survive a decade of low yields. Or look at this drought here. Even though there's more and more precipitation, there's a wicked drought. So again, it seems like the way to deal with this kind of climate change is to store carbon and store water in the soil. Do you know where I'm going? And I can see Mike smiling. I think that's why he asked me to come. He likes that message. You have to find a way of farming that will enable you to survive a year or two or more of drought and take advantage of excess water without draining. You drain, and where does the excess water end up? In the river system and in Hudson Bay, right? So we have a infiltration problem, and it's only going to get worse if we can swing from one, you see that peak there, and a couple of years later, excessive dryness. So the range between what's dry and what's wet is getting bigger in a warmer climate. Okay, so next week I'll be in southern Alberta because they got a huge problem there. You can see that this is from Ag Canada, fantastic website, agroclimatic maps. This is the drought index, and actually the entire prairies pretty much is in a drought situation, but especially those dark brown and black areas. And in southern Alberta, they have not only an agricultural drought, but they have a hydrological drought where there are municipalities that are running out of water, like Pincher Creek. And they're on the verge of telling people there's no more water. You can have water to drink and brush your teeth and go to the bathroom, and that's it. So I get this question all the time. Is this the worst ever? Is this as bad as it gets? Well, our lab is in a unique situation to answer that question because there we go. We have a long view of prairie climate. The editor of this magazine gave it a different name. They said talking trees. Okay, I called it a long view of water and climate because we've been collecting wood for decades. And this magazine asked me to write an article. They didn't put me on the cover, but I still have my job. This guy lost his job last year.
I think you probably get paid.
Yeah, I'm sure he did. He's still smiling out at Viking, Alberta there. We've been collecting wood, wrong way, for decades at every one of these little points because trees are a plant, they need water. And so the growth of the tree tells you how much water was in the soil. Trees are part of the hydrological cycle, and they live for thousands of years. Not here, but other places they do. And you notice we have some sites around here. This is in the Qu'Appelle and the Sauchyn River valleys, where we're collecting oak. And one reason I wanted to come out here was I'm still looking for oak. I know that there's some oak trees around here. We're out in the confluence of the Capel and the Assiniboine rivers at St. Lazare. Beautiful spot, especially on a fall day. And collecting oak. We were down in North Dakota. There's some big oak trees. These oak trees are 200 years old. I'm sure there are oak trees that are 300 years old. And also, oak is a hardwood. It doesn't rot very much, so I'm sure there's dead oak trees that are even older if we can find them. So if you know anybody that has oak trees nearby, just let me know. Because we're able to determine from the tree rings how much water was in the soil every year for the life of the tree. And here's our record from this part of the world. This is the amount of water in the Assiniboine River at Kamsack, just over here, every year back to 1790. And if it was a lot of water, it's blue. If there wasn't much water, it's red. And we all know that this is up to 2018. The early part of the 2010s were wet, really wet. And in fact, wetter than any time in the last more than 200 years. Except one year, 1852, there was a huge flood on the Assiniboine River. That is very well known because there was a colony, a Red River colony on the Assiniboine and Red, right? So they describe that big flood, and the tree rings pick it out. So we have this record of wet and dry. And in terms of dry, look at this. I should use the pointer. The 1860s, about 10 dry years. And I found a really cool book called Steamboats on the Assiniboia. In the 1860s, they ran steamboats up and down the Assiniboine River. There were years in which they had to dry dock the steamboats. There wasn't enough water in the river to support the steamboat. So that kind of drought lasting a decade will reoccur sometime, hopefully not soon, not in our lifetime. But when it does, it'll be in a warmer climate. So this goes back to 1790. Now, you probably noticed on that map I showed we had a lot of sites west of here. In fact, we've collected wood in Alberta that goes back to the year 542. So we have a record for southern Alberta that's 1,500 years long of soil moisture. From big old limber pine in the foothills, and from this dead wood that's been lying there for a long time, and even from log cabins in the Cypress Hills that were built 140 years ago, from trees that at that point were hundreds of years old. Okay, so we have this big record. And in this record that's 1,500 years old, we find droughts that are way worse than anything that we've experienced, unless your family is indigenous. Droughts that lasted decades, and they will reoccur in the future, but in a warmer climate. So that is the worst possible news for the prairies. 10, 15 years without water, and in a warmer climate. And these droughts, one in particular, there was a drought in the 1850s, 1860s, and a guy named Captain John Palliser was sent out here to tell the government if the area should be settled for agriculture. And you know what he said? Forget it. He said, don't come here. It'll be forever comparatively useless, is what exact words. And it's called Palliser's Triangle. But of course, and then the government did send settlers. And in the Medicine Hat newspaper, they said it was criminal. Because this is 1891, there were still people around who had lived through that 15-year drought. And they said, what are you doing? Well, my grandfather came. and homesteaded. So there's my grandpa disking the prairie sod in the homestead. And not great farming practices, but of course they didn't know anything else. Plus his fiance was coming out. And I'm sure he's thinking, I got to get a crop and I got to get some income and I got to build a shed. Otherwise my fiance isn't going to come out west. She eventually did. And of course the 1930s came along and the homestead blew away. So like a lot of homesteaders, they had to move into the parkland where they thrived. There's my grandpa stooking wheat in the farm where I spent the summers as a kid. And of course, the consequence of the 1930s was stuff like this. Now, in terms of meteorology, those droughts weren't really that bad, but the farming practices were terrible. I mean, there were a couple of really dry years, like 37, 31. But 1988, 2001, 2021 were just as bad as the 1930s, but farming practices were so much better that you didn't see this in 2021, or I didn't see it. And as a result of all of that soil degradation up until about the 1980s, here's a map of the world showing in red all the degraded soils. And of course, throughout the Western Plains, a lot of degraded soil, and up into Canada, soil which is thinner and less fertile and less organic matter content than nearby native prairie Chernozem. That's what this study determined. So there's actually an opportunity. This created an opportunity whereby farmers today have a chance to regenerate or restore the fertility of these soils because people like my grandparents degraded the soil. And I don't fault them for doing that. They were just, okay? So this is the part of my talk, just a few slides, where I don't really need to talk because this audience knows the means by which the soil health can be restored. I got this from your website, Mike. Fantastic stuff at your website. Principles of soil. I don't need, in fact, I don't have to endorse regenerative agriculture because I'm not a producer. I'm not in that business. But I can say that it makes perfect sense if you look at the future climate we expect. Okay, so if you want to be resilient and prepared for that future climate, this seems like a good solution from the perspective of climate science. And the whole concept of regenerative agriculture fits nicely within the concept of nature-based solutions. So nature-based solutions, working with nature, restoring, protecting, creating, or regenerating. There's a lot of compatibility between regenerative agriculture and the broader domain, if you will, of nature-based solutions. So I'm in the business of climate change and climate adaptation, and nature-based adaptation is being promoted as an alternative to industrial scale geoengineering of the earth. And you know, and just a couple more slides. A few years ago, I saw this article in 2018 in the magazine Alberta Farmer. Okay, regenerative agriculture, sounds cool. And then the same magazine, 4 years later, is all the rage. Really? I thought, is all the rage? I think there's just a few radical producers that are jumping on the bandwagon. Well, as it turns out, at the same time, I was asked to speak at the Western Canadian Conference on Soil Health and Grazing, which was held in Edmonton 2 months later. And so I thought, okay, I'll put together a presentation and I'll go into some ballroom hotel room in Edmonton. There'll be a few radical ag producers. I went there. There were 450 people in the room, and it was sold out. They had to turn away a lot of ag producers and agronomists. And I stuck around. I didn't just give my talk and get out of there. I stuck around for the whole conference and heard a whole series of really cool presentations by ag producers and agronomists about why this is a good idea. And something else I found influential was books like these. If you're like me, you got a bunch of books on your bookshelf you never read. So I've yet to read the two on the right. But Christmas 2018, my wife gave me Gabe Brown's book. It had just been published, and I couldn't put it down. I felt sorry for our kids and grandkids. Well, we didn't have grandkids yet. Grandkids were just about there, but our kids, I felt sorry for them because I was engrossed in this book at Christmas time, but I couldn't put it down. And the book on the right, I haven't read, but I quote it because there's a passage in that book that I've seen that points out that humus or humus and human have the same root. And so that restoring healthy soil is one of the best investments we can make in humanity's future. The answer is right at our feet. Okay, so again, I'm not here to promote regen agriculture. I don't have to this crowd, and it's not my business, but I'll say it one more time, it makes perfect sense as an adaptation to climate change.